Hi, I'm Victoria Bibagalin Jr. from College of Accounting and Education, Bachelor of Science in Accounting Information System. So today I'm discussing about statistics, particularly in Rand's test. So first we need to define what is Rand's test. So Rand's test is also known as a one-sample Rand's test. It is a non-parametric test for randomness. It is used to determine whether the order or sequence of observation in a sample is random. So here are the hypotheses. For H sub 0, it means that the observation in the sample are randomly generated. For our alternative 1 or the H sub 1, the observation in the sample are not randomly generated. So we have two methods of calculating our runs. For small sample runs test, when n is less than 20, we use that small sample runs test. And for large sample runs test, when n is greater than 20, that's the time we use the large sample runs test. So here are our examples for runs. A data scientist carrying out a research interviewed 10 persons during a survey. We denote the genders of the people by M for men and W for women, assuming that respondents were chosen as follows. For scenario 1, we have 2 runs, and for scenario 2, we have 10 runs, and for scenario 3, we have only 5 runs. So scenario 1 has only 2 runs, and therefore the scenario cannot be considered random because there are too few runs. Scenario 2 has too many runs, 10 runs, and therefore would not be considered as random. So for scenario 3, we have 5 runs, and therefore we need to perform a test to determine the randomness of the data. So run test procedure. First, we need to assume that the data available for the analysis consists of sequence of observation recorded in order of occurrence, which we can categorize into two mutual exclusive types. First, we need to determine the total sample size, then the number of observations of each type. So for n, it is equal to sample size. For n1, the number of observation of one type, and for n2, the number of observation of the other type. So here are our examples. Example 1. For small sample runs test. So example, 26 cola drinkers are randomly selected to determine whether they drink regular Coke or Diet Coke. The sample contains 18 regular Coke drinkers and 8 Diet Coke drinkers. Suppose the sequence of sample Coke drinkers. So for step 1, hypothesis. So A sub 0, the observation in sample were generated randomly, and A sub 1, the observation in sample were not generated randomly. So find that test statistics randoms are. So N1 is equal to 18 regular Coke, and for N2 is equal to 8 Diet Coke. So step 3, find the critical value. So our alpha value is 0.05 when it's one-tailed, and when it's two-tailed, it's become 0.025. It will be divided into 2. So to identify our critical value, we need to use the table of statistical runs. There we can get the 7 and 17 for our N1 18 and for N2 8. So we get 7 and 17. So fourth step, make your decision. So now we can calculate our R. So our runs is total of 12 runs. So as you can see, there are 12 runs. So since our runs is 12, falls in the range of 7 and 17. So the decision is fails to reject the null hypothesis. And for the last step, draw a conclusion. So critical range seen from table 11 and 12, 7 and 17, where 12 runs is belonging in a range. Therefore, we fail to reject our null hypothesis. We presume that the sequence is generated randomly selected. So this table are the decision rules. Is also called the acceptance or rejections criteria. It depends on the test statistics calculated and the values of upper and lower limits from statistical table. So for example 2, on a commuter train, the conductor wants to see whether the passengers entering a train enter a random manner. So he observes the first 25 people with the following sequence of males for n and females for n. So test for randomness with an alpha of 0.05. So first step would be state the analysis or state the hypothesis. So first one, the A sub 0, the pattern of occurrence of males and females in the enter the train is random. So it's sub 1 or our alternative 1, the pattern of occurrence of males and females entering the train is not random. So for step 2, find the test statistic number of runs. Now you can easily get this by grouping each run as shown below. So first run, first, second run, third run, and so on. So test statistics are, there are a total of 10 runs. So for N1, the number of females is 15 and the number of males for N2 is 10. So first, step 3, find the critical value. Now we have the in N1 and N2. So 15 and 10. 15 and 10. So now, as we can identify our critical value by using these two type, the N1 and N2. So now we can see in the table of statistic table for runs, then the lower critical value is equal to 7 and the upper critical value is 18. So for step 4, now you can make your decision. Since our runs is equal to 10, which is between 7 and 18, we accept the null hypothesis or we fail to reject it. So now, for step 5, for our conclusion, there are not enough evidence to reject the claim that the pattern of occurrence of males and females enter the train is determined by a random process. Now, we also have here the large sample runs test examples. So if the N1 and N2 is greater than 20, so sample distribution of R is approximately normal with a mean of standard deviation. Here our formula. So for our mean, 2N1 N2 over N1 plus N2 plus 1. For standard deviation, we have here the square root of 2N1 N2 and parenthesis 2N1 N2 minus N1 minus N2 over parenthesis of N1 plus N2 square root of then N1 plus N2 minus 1. Now here is the example of the large sample runs test. So a machine produces parts that are occasionally flowed when the machine is working in adjustment. Flows still occurs but seem to happen randomly. A quality control person randomly selected 50 of the parts produced by the machine today and examined them one at a time. The other day that they made. The result is 40 parts with no flows and 10 parts with flows. Using level of significance is equal to 0.05. The quality controller test to determine. So first step would be the hypothesis, of course. H sub 0, the observation sample were generated randomly and the observation and sample were not generated randomly. Second step, test statistics. So now we have here the mu of R is equal to N1 N2 over N1 plus N2 plus 1. So therefore, to substitute that data, we have the 2, 40, 10, 40, 10 plus 1 is equal to 17. So the mean, our mean is 17. For our standard deviation, we need to do is to substitute the data. So here, with a total of 2.213 for our standard deviation. And for step 3, we need to identify our level of significance, 0.02. Divided by 2 when 2 tailed, 0.025. So the critical value for significance of 0.05 is negative 1.96 or 1.96, positive negative 1.96. So now we can calculate the runs. So we have 13 runs. So now we can assume that now we can compute our z-test. So for the formula of z-test, we have here the R is minus the mean over standard deviation. So we need to substitute the data, 13 minus 17 over 2. So since now we already done computing our z-test with the value of negative 1.81, now it's time for us to comparing our calculated value with critical value. So our z value is negative 1.81 while our critical value is 1.96. So therefore, we do not reject the null hypothesis and we consider that machine flaws are randomly noticed. So here are our other examples for small runs. So we have 20 people that enrolled in a drug abuse program. Test the claim that the ages of the people according to the order in which they enroll occur at random with at alpha of equals to 1.05. The data are as follows: 18, 36, 19, and so on. So for first step, we need to identify our hypothesis. So the claim is the null and the hypothesis, the alternative hypothesis is sub 1. So A sub 0, the pattern of the occurrence of ages of the people enrolled in a drug abuse program is determined by random process. And for each sub 1, the pattern of occurrence of an ages of people enrolled in the drug abuse program is not random. For step 2, find the test statistic or the number of runs. To find the number of runs, we first arrange the data in ascending order and find the median of the data set. So here's the result. So BA, BBA. So since our we already computed our median, so now we can determine if it is B or A. When B it is below the median and A is above the median. So we can now arrange the data according to runs, and we would have to output below BA, BB, ABBA, ABB. So from the above we have the runs is equal to 9. Then N1 number of runs is equal to 9. N2 number of runs of B is equal to 9. So step 3, find the critical value. Since we already had the 9 for N1, 9 for N2. So from statistical table of runs test, we get the critical values. For upper critical value, 5. For lower critical value is equal to 15. For step 4, make decision. Since the statistic R is between the upper and lower critical values, we accept the A sub 0. So therefore, we conclude that there is not enough evidence to reject the claim that the pattern of occurrence of ages of people in the program is determined by random process.